Morning students, today I will deal with the topic domain and range of a function. So it is very important from competition point of view. We have already discussed domain means all the values of x for which your fx is defined. For example, let me take a function fx which is equal to 2x minus 7, right? Now I want to find the domain of this function. Can you see this is clearly a linear function? So for every value of x I can define fx. Hence the domain will lie between minus infinity to infinity, that is set of all real numbers, that is for all real of x fx is defined. Now let us take fx equals to x square plus 3x minus 5. Now here also you can see the domain is same, because for all values of x fx is defined. Now let me take another example, 2x cube minus 5x square plus 7x minus 3. Here also we can see for all values of x fx is clearly defined. Hence the domain will be from negative infinity to positive infinity, that is set of all real numbers. Now but this is not true always that for all x fx will exist. For example, let me take this fractional function, that is 5 divided by x minus 2, and here you can see if the denominator becomes 0 then fx will not be defined. Hence I must ensure for domain that x minus 2 must not be equal to 0. So if I solve this one, this will be giving you x is not equal to 2. That is, for fx to exist, x must not be equal to 2. Now let me elaborate it with a straight line for finding the domain. Remember, for finding the domain your straight lines are very important. Okay, so now here simultaneously I must ensure also that x is not equal to 2. So here comes the straight line. Here I will place 2 in between, then in the right hand side I will go up to infinity, and in the left hand side I will go up to negative infinity. Now you can see x is not equal to 2, that means I will exclude 2, so it will be minus infinity to 2, then union 2 to infinity. You can see in both the intervals 2 is not included, that means set of all reals except 2. So this is the notation we use for finding the domain of a particular function. Now let me take another example. Suppose fx equals to 3x minus 8 divided by x square minus 9x plus 20. Okay, now I must ensure here also the denominator must not be equal to 0. So for that the same thing we will see. Remember, for every fractional function the denominator must not be equal to 0. Now let me take this one, this is x square minus 9x plus 20 must not be equal to 0. Now let me prime factorize it or split the middle term. You have to find two numbers whose sum is minus 9 and product is 20. I think the required numbers will be minus 5 and minus 4. Look at this, this is 4 and 5, that is minus 4 and minus 5. Now let me do the prime factorization of this. This is x square minus 4 and this is x minus 5 must not be equal to 0. Ultimately it will give rise to x minus 4 is not equal to 0 and x minus 5 is not equal to 0. Next, x minus 4 must not be equal to 0 and x minus 5 must not be equal to 5. So here I get x is not equal to 4 and x is also not equal to 5. So let me find out what should be the intervals in which x will exist. I will take 2 points here, 4 and 5 on the straight line. Here in the left also I will be writing minus infinity, and in the right I will be mentioning this is positive infinity. Now look at this, this will be minus infinity to 4. Next it will be union 4 to 5. Next union 5 to infinity. So this is the interval in which your fx will exist. So this is the value of x for which fx will exist. Now let us take some more examples. Suppose I take fx equals to 2x minus 3 divided by x square plus 4. Now here also I must ensure that denominator must not be equal to 0, that is x square plus 4 must not be equal to 0. Now look at this, x square must not be equal to minus 4. Now you can easily judge that x square can never be equal to minus 4. That means here for all values of x, fx will be defined, because here x square is not equal to minus 4 mentioned, and it is true for all x. Hence my domain will be the set of real numbers. So here once again you see fx divided it is x square plus 4. Hence my condition is x square is not equal to minus 4. Now if I ask you, tell me any value of x for which x square is not equal to minus 4, you can tell any value. Hence your domain will be negative infinity to positive infinity, that is the set of real numbers. Now let us proceed to the next, that is f of x equals to x minus 4 suppose. Now here remember, anything inside the square root, whatever it is, it must be either greater than or equal to 0, because square root of negative things are not defined, negative numbers particularly. That means your x minus 4 must always be greater than or equal to 0. That means x is greater than or equal to 4. So if x is greater than or equal to 4, let me draw the straight line to show this 4, and this one in the right hand side it is infinity, and in the left hand side it will be minus infinity. Now look at this, here their domain will be 4 to infinity. So 4 is included but infinity is excluded, because x is greater than or equal to 4. Now let us discuss the next one, that is fx equals to square root of x square plus 3x minus 28. Same thing, since the things are inside the square root, so I must ensure that whatever inside the square root must be greater than or equal to 0. So for that, first I will factorize this one, middle term splitting. Now look at this, this is x square plus 3x minus 28. So I have to search for two numbers whose sum is 3 and product is minus 28. So it will be 7 and 4. So this will plus 7 and this will be minus 4. So here I will be writing this one as x minus 4 multiplied by x plus 7 must be greater than or equal to 0. Now how to solve this one? This is a product one. First you solve this one, x equals to 4 and x equals to minus 7. Now you place 4 and minus 7 in the number line. Now after that you judge for which value of x this interval is satisfied. Now I have three intervals here. One is minus infinity to minus 7, and this one is minus 7 to 4 and 4 to infinity. So now let us see which interval is satisfying our condition. Our condition is x minus 4 into x minus plus 7 it must be greater than or equal to 0. So if I take any value in the interval of minus infinity to minus 7, so this number it will be negative, sorry I am talking about after 4, so this number will be positive and this number will be positive. So it is satisfied. Now let us see the interval between minus 7 to 4. Now look at this, here x minus 4 will be negative but x plus 7 it will be positive. So this interval it will be negative. Now let us take any number between minus infinity to minus 7. In that interval this one will become negative and this one will also become negative. So negative negative it will become positive. So now I need that the product must be positive. Hence the rotations or the intervals which are satisfying this interval is this one, that is minus 7 infinity to minus 7, and another one is 4 to infinity. So let me write it elaborately. So the required interval, it will be minus infinity to minus 7, and next interval it will be 4 to infinity. That is, x is less than equal to minus 7 and x is greater than equal to 4. So your domain will be minus infinity to minus 7 union 4 to infinity. I should exclude minus 7 to 4. So this is the required interval, and be careful while using big brackets and small brackets. If it is greater than equal to, it will be 7, and if it is less than equal to, it will be big bracket, and if it is only less or greater, then it will be small bracket. Now let's proceed to the next question. What I am getting is 2x minus 7 divided by square root of x plus 3. Now in this, first I have to ensure two things, that is, x plus 3 must not be equal to 0, and also it should be greater than equal to 0. Why? Because if x plus 3 is 0, then fx will not be defined. So x plus 3 will be strictly greater than 0. Equal to 0 will not satisfy this, that is, x is greater than minus 3. So your domain will be minus 3 to infinity. Similarly, you can draw straight line and demonstrate this. Now let's proceed to the next one. Suppose I take f of x equals to root under x minus 4 divided by x square minus 25. So now same thing here, x square minus 25 must not be equal to 0. Simultaneously x minus 4, since it is inside the square root, it should also be greater than 0. So from the first condition, that is x minus 4 is greater than equal to 0, I get x is greater than equal to 4. From the second condition, x square minus 25 is not equal to 0, I will get x plus 5 into x minus 5 is not equal to 0, that is, x must not be equal to 5 or minus 5. Now let us decide the interval. Draw a straight line, mark those points, minus 5, this is 4 and this is 5. So here, if it is so, then let us see, minus 5 and 5 will be excluded. So I have given the circle over there, since they are excluded, but 4 will be included. Now the interval says it is greater than or equal to 4. Look at this, x is greater than or equal to 4. Now let us decide what interval it will be. Now when we say domain, regarding domain, this will be 4 to 5 first, since 5 is not included, then I will give a small bracket here, then union 5 to infinity. Also here I will not include 5, as well as infinity is obviously not included. So be careful while giving the proper symbols of big bracket or small bracket. Now let's see the next one. Suppose fx is a root under x plus 3, that is square root of x square minus 16 divided by square root of x square minus 16. Now here also many things you have to see. First one is x plus 3 greater than or equal to 0. Second one is x, from that I will get x is greater than or equal to minus 3, and minus 3 I have marked here. Next it is also included, then it will be infinity. Now this is infinity. Now let us talk about this. So here I get x square minus 16 is greater than 0. Therefore I should get, since it is in the denominator, it can be equal to, right? It cannot be equal to. So if it is so, x square minus 16 is greater than 0, then x plus 4 into x minus 4, watch carefully, minus 4 is greater than 0. Hence I will get x equals to, first you solve it, that is plus 4 and minus 4. Now again you would draw a straight line for solving this kind of equations. This is minus 4, this is plus 4. Now you take a value between or before 4 or after 4 and minus 4 to 4. So since I was having these two, so I will be dividing the straight line into 3 intervals. Since x is not equal to minus 4, so I will not include this. Similarly, I will also not include your 4. Then let us see how to find the domain. So in the first condition, here it will be plus and it will be minus. So hence minus 3 to infinity will prevail. Next, let me talk about this one. If I take any point after 4, this is satisfying the equation. So between 4 to infinity, it will be positive, and this will also become positive. X minus 4 will also become positive. So here positive and positive, it will become positive. Now let us talk about the second interval. Here minus 4 to 4, this will be positive and this will be negative. So this interval will become negative. Now before minus 4, this one will be negative, this one will also become negative. Hence negative negative, it will become positive. So whatever plus I write, you keep just those intervals. Now look at this, what I get as a domain. In the first condition I saw it is minus 3 to infinity, and in the second interval I saw minus 4 to 4 will not exist. Hence it will be minus infinity to minus 4 and 4 to infinity. So but remember, both the intervals must simultaneously occur. So how to write it properly at last, that is very important part of this question. Try to understand it. So at last you draw another straight line, you fill this one minus 4, then minus 3 and 4, then minus 3 to minus infinity to infinity. Again look at this, from the first one I got minus 3 to infinity, so it will be minus 3 to infinity. In this side it will be, so look at this. So here I am getting minus 3 to infinity, it should be the one which is existing. Now 4 to infinity is also correct, so minus 3 to 4 will exist, as well as 4 to infinity. From the second interval I will take, this will be 4 to infinity. Okay, so here both the intervals are satisfied by the interval that is 4 to infinity. Hence it is important for us to write that the domain will lie between 4 to infinity. So you should see, as I have told, both the intervals must simultaneously be satisfied. So 4 to infinity is satisfying the first one as well as it is satisfying the second one. Hence we are having at last that the domain will be 4 to infinity. So likewise we can solve so many questions on domain and range. So remember two things: if it is inside the square root, the things must be greater than or equal to 0. If it is inside the denominator, the things must not be equal to 0. By ensuring those only, you will find the domain and range for all the questions. So you practice yourself many questions from 11th class exemplar book they have given, and you solve your questions. That's all for today. Thank you very much.